Should we allow AI machines to flood the internet with propaganda and fake news?
People are going to try to disrupt democracy by making an atmosphere where we can't really trust anything.
It can analyze thousands of words of text to create almost anything.
When we think about AI, often we just think about the applications. What we're not thinking about so much is the massive infrastructure behind the screen that's needed. First of all,
the biggest conversation out there right now is around artificial intelligence. The issue, though, is that AI algorithms are huge.
Power consumption in the data centers is just going through the roof.
GPT-3 took something like 300,000 exaflops of computing power to train. With an ordinary high-end PC, it could take something like 200 to 300 years.
To run an AI algorithm is incredibly expensive. Takes a huge amount of computational resources, and then you have to train it, which means putting it through its paces until it's actually giving accurate answers to queries.
Power consumption for high-performance computing is just going sky high. They're predicting a compounded annual growth rate of somewhere around 8.5%. AI workloads will account for about 80% of that power.
We set out on the challenge to be able to address all of the machine learning workloads that people are running today, but using a new technology platform, Photonics.
The team here has figured out a way to combine electronics, photonics, and algorithms to create a breakthrough computing platform that is mission built to be able to run the biggest neural networks and AI models in the world.
I'm always fascinated by light, in the nature of light. It's amazing. The way that we can capture light and then put it into our chip and then manipulate it and then transfer information with it, that's all amazing. Processors that exist, that you have in your cell phone, in your computer, works with electrons. I mean, if you compare electron and the light, the photon is much, much faster.
Moore's law is still going strong. Process nodes are getting smaller and smaller, and they're jamming more transistors in every CPU that gets made today. But there's also a companion law called Dennard scaling. As the process nodes shrank, the leakage of the small geometries started to become more and more impactful to the power consumption. And so Dennard scaling no longer really applies. So it's really hard for chip companies to be able to get that performance up now without really burning a ton of power.
There are so many Band-Aid solutions that are out there, and there's more coming. It's just, tape on the pipe that's burst.
This is happening at the same time that AI is really taking off.
ChatGPT was trained using 10,000 GPUs. Now you need something like 25,000 GPUs to train the cutting-edge models.
So it's actually growing exponentially, and the rate is 5 times faster than Moore's law. So you're really not going to be able to keep up with this sort of demand unless you have a new technology.
Lightmatter's approach is to use silicon photonics to be able to increase that performance, but use much less power to do it.
Talk about that extreme performance. What kind of performance boost am I getting?
On typical workloads, we're up to 10 times faster than existing technologies like NVIDIA's A100 chip.
I work at Lightmatter because I like startups in general. At a startup, you're inventing something that doesn't exist. This is my third startup, and I know that eventually you get to the point where you have so many products and you're working with a contract manufacturer to build 3 or 4 or 5 different things. And you can't just exchange data over spreadsheets. You make mistakes. You send them the wrong version of a spreadsheet. They go off and they build something that has a wrong value component in it. Next thing you know, you've got 5 prototypes that you have to rework by hand to fix a problem because they don't have access to the latest and greatest data. So we're using Altium Enterprise. It's a cloud-based application. It was important that there was a connection between the schematic design tool and the PLM tools. Those are important things for us to be able to meet our schedules and not have to iterate 10 times to get things to work.
Data is not really the bottleneck. Scraping the entire internet is actually not that expensive. The real bottleneck is compute.
The idea of photonics has been a bit of a holy grail in computing for a long time.
It's totally unique than anything that exists today. It has lasers that need to have light shining in the chip. We need to have fibers that connect to our chip to the lasers themselves. We actually have to not just build the chip, but we also have to build the boards that the chip goes onto.
We are working on something that has not been done before. So imagine that you're working at Apple before the iPhone.
What we're doing at Lightmatter is we're designing that GPU server. And so it starts with designing the PCIe card, where we will basically be able to take our chip, install it on that PCIe card, put a bunch of those into a server, and be able to install that in a data center.
To me, it's incredibly exciting because it's at the bleeding edge of innovation, and again, it's a real solution. It's not just funny stuff in a garage. We're testing prototypes, mechanical samples right now that are working. So it's just incredible. The stuff is real now. Like the competitive product guy in me is super excited because, you know, I literally have samples to photograph now.
Thank you for watching Altium Stories. If you found this story inspiring, don't forget to hit the like button and share it with your friends and colleagues. By subscribing and hitting the bell icon, you'll never miss out on the latest engineering stories from our channel. We would love to hear your thoughts, so please comment and let us know your favorite engineering story. Thank you for supporting us and helping us continue to share the impactful work being done by engineers around the world.